Okay, you have two equations. One is a hyperbola, and the other one is going to be a line. My recommendation is to solve it the way you've done in the past. And if you do that, you're going to find out there's one real point of intersection, and that's at -5 comma -4. I also recommend, like we've done in the past, to graph it out. Let me point out what I mean by that. Not that one, sorry about that. This one over here, and there is a point of intersection over here. Now, granted, looking at this, it sure does look like there's a lot of points of intersection there. Like, for example, if you zoomed in on my notes, you notice over there, it looks like there's a big band of points of intersection, but there's only one point of intersection. So what I want to do is I want to go to graphic software and kind of zoom into that region over there. Now, granted, I still have the old problem up. I'm going to have to pull this back, and let's do it. And I'm gonna type that in. And what's that going to be? X squared. Let's see, minus y squared. And that equals 9. Again, we're going to do the other one now, which is going to be, and again, I have to readjust my axes to see the picture, by the way. 5x minus 4y equals -9. And let me zoom out until I see the picture. And let me get rid of these two over here, all right, just for a time being. So I'm going to zoom out a little bit more. And what I'm going to do is I'm going to drag the curve around because I kind of see that there's going to be a point of intersection over here. Now, granted, you could zoom out more. Let me just show you what I mean by that. And I hope you realize that, zooming out more, I hope you realize that the line and the hyperbola appear to intersect only over here, all right? Let me zoom back in. And let me drag it around. And I got to be honest with you, looking over here, this might be a tough call on what it is, right? So what I want to do is I want to kind of zoom into that region. And let me get my little zoom in there. And on this region, I don't know, maybe something like this over here. All right. Now, again, ballparking it, right? What's the problem with ballparking? You could be dead wrong. So I'm going to say it looks like x is -5 to me. Well, and then it looks like the y, it looks like -4 to me. And you know, I know they certainly things seem to come together there. I could not testify this is the truth though. However, if I went back to the original system and I solved it, I would get that point of intersection, -5, -4. You should also verify it numerically that it satisfies the system of equations. That means that this point here satisfies this equation and satisfies this equation. It's a point they share. It's the only real point they share. Thank you.